All right, here we are at section 5.4, running hypothesis test for two proportions. Here is another example problem. It says you wish to test the following claim at a significance level of alpha equals 0.10. So maybe I should just write this down now. Probably been saving it for later in most of the other ones. Our null hypothesis is that p sub 1 is equal to p sub 2, and our alternate hypothesis that p sub 1 is greater than p sub 2. So we are dealing with a right-tailed test on this one. You obtain 231 successes. So if I have my, let's see, that would be x sub 1 is 231. And then our sample size n sub 1 is 790. And we can use that to find p sub 1, just taking our successes and dividing by our sample size. Now, you obtain 120 successes in a sample of size. So this is x sub 2, 190. And our sample size, n sub 2, 787. Giving us a p sub 2 of 190 divided by 787. I'll zoom in on that a little bit, make it a little easier. So next up, we need to find our pooled proportion. So that's p sub c. And to do that, we add up, probably did that more than I needed to here, the sum of the successes, so x sub 1 and x sub 2, divided by the sum of the sample sizes, n sub 1 and n sub 2. And we get a pooled proportion here of this. We'll use our pooled proportion and our sample sizes to figure out our standard error. It's the square root of this pooled proportion times 1 minus the very same pooled proportion, and 1 over n sub 1 plus 1 over n sub 2. And another set of parentheses so it doesn't bark at me too much. Interesting. Alright, next up we can use our proportions and our standard error to find our test statistic. And for that I need the difference, p sub 1 minus p sub 2 over our standard error, and I get a test statistic. Now, figuring out my p-value, I've got a normal distribution. My test statistic is 2.28, and this is a right-tailed test. So we're looking for that area over there for our p-value. So we're looking for the area to the right. Excel is limited to the area to the left. So I'll do a normal standard distribution. Click this guy and true. And we get that area to the right. Now we should still be able to use test for reasonableness here. We have a 2.2, which is more than 2 standard deviations over here. This is a 1.1%, so kind of makes sense. All right, so entering in our answers. Okay, guess we didn't share this guy here. There it is. Now that'll work a little bit better. 2.288, and it's followed by a 3. Our p-value is 0.011, and then a 0, which is followed by a 6, so that would round up. Our p-value is, I almost said it's greater than alpha, but we have another 0 here. So our p-value is less than alpha, which means we reject the null hypothesis. So in this case, there is enough evidence at the alpha equals 0.10 level to conclude that proportion 1 is greater than proportion 2. Easy for me to say. All right, let's throw an additional example in here. start another one. You wish to test the claim here. Okay, we got an alpha early on, 0.05. Zoom in a little bit. You obtain a 35.6 success, so P sub 1, 0.356. N sub 1, 635. And I can use those to find X sub 1. It's going to be the product of the probability of success multiplied by the sample size, which it doesn't like me grabbing here for some reason. But again, that's this times this. You obtain a 34.3 success rate in a sample size, so that's P sub 2, 0.343. N sub 2, 680, and we can get X sub 2, this guy times this guy. Let's just go here and down a couple. Not sure why it's being weird, but it is. Okay, we use those to find our pooled proportion. That's P sub C. I might often say pooled probability. Same kind of thing. So we add up the successes and divide by the sum of the n's. It really should be here. I have to go back here and fix this to be 4. If I did something like that, it might give me a really wonky answer, and that should alarm me a little bit if I make an error. So I can use this to find my standard error now. It's going to be the square root of my pooled proportion times 1 minus my pooled proportion times 1 over n sub 1 plus 1 over n sub 2. Close that and close it again. There's my standard error. Now I can find my test statistic by taking the difference of the proportions, P sub 1 minus P sub 2, and dividing by the standard error. So here I have a normal distribution, and my test statistic is almost 0.5, right? So it's right over here. And notice this one, this is a two-tailed test, so we actually have to find the area over here and then double it, so to find our p-value. So we're going to go, depending if we're positive, we find the area to the right. If we're negative, we find the area to the left. So it's going to be 2 times, and now I have to find the area to the left, 1 minus a normal standard distribution of this, and true. And we had to do that again. We have to find the area to the right of this. Our function only finds the area to the left. So do we do 1 minus the normal standard distribution of our test statistic to find this area, and we double it because it's two-tailed, and so I think I need another parenthesis. Again, the p-values can be a little difficult. The picture is really helpful for that. So then we make a comparison of our p-value to our alpha. In this case, our p-value is much greater than alpha. And so we would fail to reject the null hypothesis. So our test statistic was 0.4941, so 494 to 3 decimal places. And our p-value 0.6212, followed by another 2, so rounding it to 4 decimal places, we are there. All right. So again, a couple of problems here with our hypothesis test for 2 proportions. Let me know if you have any questions. Thanks.